What's poppin', dogs? Mr. Allen here with some absolute value inequalities. We're going to be graphing these bad boys on number lines. I mean, it's just going to be an absolute blast right now. So let's get after it. All right, first one. My absolute value right here is not on its own side of the inequality. We solve these the exact same way that we would solve an equation, an absolute value equation. We got to isolate that absolute value first. Sorry, smudge that a little bit. Whoop, there we go. All right, so I'm going to add 2 on both sides first. So now I have the absolute value of x plus 4 is greater than or equal to positive 12. Cool. Next up, do I have my absolute value isolated? Yes. Can I write 2 different inequalities? Absolutely. So the first one here is x plus 4 is greater than or equal to 12. But the next one, okay, this is the one little change up here from equations, is when I do x plus 4 and I have negative 12, I've got to flip-flop my inequality so it's going to be less than or equal to. Just like if you were to multiply or divide by a negative number when solving with inequalities, same kind of idea here. I change this to a negative, I got to flip-flop my sign. Cool? That's really the only difference. So now I got to subtract 4, so minus 4, minus 4. We get x is greater than or equal to, let's be positive 8. And then over here, I've got minus 4. We get x is less than or equal to negative 16. Beautiful. So we're going to put this on a number line, all right? And this is greater than or equal to 8 and less than or equal to negative 16. And I said and, but I meant to say or. Okay, these are pointing away from each other. It's going to be more apparent on our number line. I'll draw the number line right here. Usually when we do these, I'll throw like a 0 as like a placeholder. I'll have my negative 16 over here, and then I'll try to sort of scale it a little bit with the 8 right here, okay? Then, are we going to have an open or a closed circle? Well, these are both equal to, so they're both going to be closed. For the 8, it's going to be closed here, and it's greater than or equal to, so it's going to be going this away. And then for the negative 16, it's less than or equal to, so it's going to be going this away like that, all right? My final solution here is going to be x is greater than or equal to 8 or x is less than or equal to negative 16. You can really put those in either order. I guess maybe start with the negatives better, but whatever. I had them written this way. All right, and I'm running out of space. So there we go. We got our answer. We've got our graphed solution as well. Closed circle when it's equal to. Boom. We're moving on. Next one over here. Once again, my absolute value is not on its own side of the inequality. So I'm going to divide by 3 on both sides. And I've got myself x minus 1 is less than 5. Now it's on its own side, so I'll break it apart. We got x minus 1 is less than 5. And then we have x minus 1 is greater than negative 5. We got to switch that sign. All right, then I'm going to add 1 on both sides, so we get x is less than 6. And over here I'm going to get x is greater than, if I add 1, I get negative 4. Okay. Well, if x is less than 6, it's also greater than negative 4. This is going to be an and statement. And if you don't see that yet, it's okay. All right. I'm going to graph it on a number line, and then we'll write it as such. You'll see here in just a sec. So I'm going to get my number line going. Whee! We've got 0 right here. I got negative 4 right here, and we'll go a little farther away from 0 for 6. Now, these are not equal to, so it's going to be open, an open circle here. It's less than that, so I'm going to go this way. And for my x is greater than negative 4, open, and I'll connect them. Some teachers will just have you scribble between. I've seen a lot of people go like up and over so you can like see where you're drawing these lines. That's my preferred method. I'm making the video, so I'm doing that. But if your teacher has you doing something else, like just scribble in between, that's cool too. Totally works, all right? Now, you could say this right here and circle this, but I prefer to write it as a compound inequality with x in the middle. We're going to have negative 4 over here. We're going to have positive 6 right here. And that, to me, is the best way to write this one. This says x is less than, or x is greater than negative 4, and it's less than 6. You can even read it left to right. Negative 4 is less than x, which is less than 6. Cool. The graph spells it out as well. There we go. Sorry, a little bit smushed right there, but we got it done. All right. Next one over here. Ooh, we got a coefficient within. That's exciting. That's exciting. But it's not, we're not set up yet, right? We don't have the absolute value isolated. So let's subtract 6. So I've got absolute value, and we got 4x minus 2 is greater than negative 6. Now, this is interesting, right? Anytime we have an absolute value and we got a negative number going on, we're like, is that no solution? Well, this right here, greater than negative 6, it's always going to be greater than negative 6. So this is all real numbers right here, okay? So all real numbers. But I'm going to finish solving this thing out as if we didn't realize that right away. We're going to see what happens here. And sometimes your teacher might want you to still solve it all out and show it on the graph. You're going to see these things overlap, all right? So we got 4x minus 2 is greater than negative 6. 4x minus 2 is less than negative 6. I'm going to add 2. We get 4x is greater than negative 4. So x is greater than negative 1. And over here, if I add 2, I get 4x. Oops, wait. That should be positive 6. There we go. Oh, almost messed that up. All right, we get 4x. If I add 2, I get less than 8. And then we're going to have x is less than 2. Let me double check that right now. Make sure I didn't screw anything else up. We added 2. Cool. Divide by 4. Excellent. Here, we've got it less than positive 6. Close call. And we got add 2. We get 8. Divide by... Okay, cool. I think we're good, guys. I think we're good. All right. Now, when I throw this thing on a number line, all right, when I throw it here, I'm going to throw my number line down. Then we've got, I throw 0 usually. Again, it's like a reference. We got negative 1. We got positive 2. Okay. X is greater than negative 1. It's going to be an open circle, right? And it's always going to be greater than negative 1. And X is going to be less than 2. And you might be like, well, why wouldn't we just make it like an and statement like this one up here? Well, let's see here. If I were to pick, say, 3, right? Or 4. Let's go with, you know what? Let's go with 5, okay? Let's go with 5. Well, 5 works for x being greater than negative 1, but it doesn't work for the 2 over here, right? It doesn't work for the less than 2. But let's see here. If I plug in 5, I'm going to get 20 minus 2 is 18, right? Absolute value of 18 is 18, plus 6 is 24. Is 24 greater than 0? Yeah, it works. Let's apply that same thought on this one, okay? Let's pick a number that is greater than negative 4, but bigger than 6, right? Because it says x is less than 6. How about I pick 10, okay? Everybody cool with that? Everybody cool? Everybody cool with that? Everybody said they're cool. All right, so if I plugged in 10 to my original, right, I'd have 10 minus 1 is 9. Absolute value of 9 is 9 times 3 is 27. Is 27 less than 15? No, it does not work, okay? So again, it all comes down to the absolute value and you identifying that it's greater than a negative number. That's always going to be true. So we can really say here, x equals all real numbers. You could say infinitely many solutions, right? But that's what we're working with on this one here. I'm going to circle this. That is what our graph would look like there on the number line. Both of them open. Any number is going to work here. Cool? Super cool? Dope? Awesome? Fantastic. Even negative 1 would actually work. Okay? If I plugged in negative 1 here, I'm going to get 4, negative 1. That's going to be negative 4. Minus 2 is negative 6. The absolute value of that is 6. Plus 6 is 12. It's still greater than 0, so it still does work. So even though these are open circles on those values, the overlapping just basically takes that out, okay? X equals all real numbers is our solution. I'm going to stop babbling on this one. There's always a weird case happen on this one. All right. Last one over here. Let's do it. I'm going to, let's see here. I got to isolate my absolute value, so I got to subtract 5. So we're going to have 2, and then the absolute value, 3x minus 1. Less than or equal to, if I do that, I get 16 over here. Divide by 2, I got the absolute value of 3x minus 1 is less than or equal to, that's going to be 8. Now I can break it apart. So I got 3x minus 1 is less than or equal to 8. And we got 3x minus 1 is greater than or equal to negative 8. All right. Now here, I'm going to add 1, and I get myself 3x is less than or equal to 9. So x is less than or equal to 3 when I divide by 3. Over here, if I add 1, I get 3x is greater than or equal to. If I add 1, I get negative 7. So we get x is greater than or equal to negative 7 over 3. Like I was saying before, guys, a lot of times you'll get one integer, one fraction. So don't be alarmed if you end up getting fractions with these. It can be kind of tricky to make them up to where you always get integer answers. So it's likely to happen. All right, now, is this going to be an and statement or an or statement? Let's take a look at the graph here. All right, so if I graph this thing, hopefully we can see that. Let me double check. Looks like you can see that. Got a little thing on my watch. All right, so we got 0 here as a reference. 3 is going to be over here. Negative 7/3, that's like negative 2 point something, negative 2.3 repeating. So it'll be a little bit closer, but not too worried about it. Negative 7/3. Okay, cool. And then let's see here. Open or closed circles. These are going to be closed circles because it's equal to, so closed. And it's greater than negative 7/3. And over here, it's going to be less than 3. They are going to connect. It's an and statement on this one. So let's write that out. We got negative 7/3 is less than or equal to x, which is less than or equal to 3. Whee! There we go. Awesome, man. Now, one last thing I want to point out here. If you're still watching, now you get the cool stuff, okay? Greater than 12, right? Greater than. Over here, it was less than. Okay? This one's a weird one. Over here, less than. It was an and statement. Greater or is going to be an or statement. Less than is going to be an and statement. So that's another way to kind of check yourself before you rank yourself. Again, this one's a weird one, right? Because it's greater than a negative 6, right? So it ends up, but it's still like an or. So if you think about this as an or statement, when the arrows point away from each other, we had the arrows go past each other. So it still kind of jives with that. But all right, guys, absolute value inequalities, an absolute blast. Absolutely gets a little crazy sometimes, but I absolutely love solving them. I'm absolutely done with this video. See ya.